Hello guys, we're going to look at the blocking queue on this session. So we saw that the blocking queue falls under concurrent collection. So we're gonna see how it works. So what I have here for the demonstration, I have a situation where people are scheduling interviews, and then interviewers are interviewing those people who have scheduled for interviews. So scheduling of interviews, we are using blocking queue. All that we do with this blocking queue is that we create a candidate, we put the candidate into queue. Then we mention that the candidate has entered, we can say he has entered, okay, we can say scheduled. For interview. We are doing the schedule for interview. Then what we do here, a candidate is interviewed. So that's it. So what we are doing here, we are putting candidates in the queue to be scheduled. And after we've put a candidate as scheduled for interview, this is what this class does. Then when all the candidates are completed scheduling, what do? We just we mention that interview schedule for all candidates has been done. Then we can send a complete to say we have complete, or we can say closed or something like that, whatever you want to do, just for demonstration purposes. Then we also, on the other hand, have an interview desk that will actually take those people that have been scheduled for interview and interview them. And these people are coming in a queue. So what we want to do here is, as you can see here, we have a blocking queue. As I said, we are only going to work with array blocking queue. It's your responsibility to look at the other implementations of it, linked, deck, priority, synchronous, as I've mentioned. So as you can see, this blocking queue is fair, which means that it will try to take people in the order in which they arrived or they scheduled for an interview. And then, as I said before, going forward, we're going to use Executor to actually send tasks. So we see we're using new fixed ThreadPool. We are giving it 5. We are saying we need 5 threads, which will actually execute all this work for us. So what we are doing here, we are just going to run this code. I'm just going to run it. So as you can see, we're having candidate arriving and being interviewed. Just going to decrease this number to 3. So if you reduce this number, it will obviously affect how the scheduling is done. You saw that when we had 5 here, the candidates that are scheduled, we see that there were actually 5. When we reduce it to 2, we see that we have 3 that are entering the thing. And so how does the before we even go there, we see that this variable, which will so what we have to understand what this thing does, it gives us the number of threads that can execute tasks for us. That's what we have to understand. So if you are submitting how many tasks? 1, 2, 3, 4 tasks, but you have 2 threads to work on that. And you see also that the number of this has an effect to this number here. You see here that we say our queue can actually contain only contain 2 tasks or 2 interviewers in the queue. When you try to put stuff in the queue, because the queue is full, the others will have to wait. It's like when you are maybe in the bank, you are in the bank, then you are in a queue to be serviced. Normally they will call maybe 5 people in the bank. They will tell you that it's full. When the 5 people are serviced, they will take 5 more again. Or in some situation, you find that if they have taken 5 and 2 have been serviced, they will ask 2 to come in. So this is exactly how this thing is working for us. But that is not that much to be worried about. What we need to understand here, I'm going to remove this true here, which actually introduces our queue to be fair. So if we remove that, we are going to observe that there's going to be some differences as well. You can find that some like interviewers that arrived late get interviewed before the interviewers that arrived before them. This is what we can see that it could happen. You don't have fairness in that regard. So it doesn't guarantee fairness. You can still have fairness, but it doesn't guarantee fairness for you. So to make it fair, let's just put it through here. This is it. So let's just run it again. So what is happening here? All right, we see that candidate 1 entered the interview, candidate 2, that candidate 3 entered. So basically we have 3 candidates that entered the interview room. Then we see that candidate 1 was interviewed, candidate 2 was interviewed. Because now they have been taken out of the queue, we are allowed to add another candidate to the queue. And candidate 3 got interviewed, we got another one added. So the order is not that much predictable. But the fact is, when a queue is full, it will not allow more people to come in because it's full. But after you come here on the interview desk, you take out something from the queue. You create room for something else to come into the queue. That is what you have to understand with the blocking queue. So let's just read the Java doc for it. It says a queue that traditionally supports operations that wait for queue to become non-empty when retrieving an element, and wait for space to become available in the queue when storing an element. You wait for space to become available. So blocking methods come in 4 forms with different ways of handling operations that cannot be satisfied immediately. Let's look at this implementation here and see what they say. Say a bounded blocking queue backed by an array. This queue orders elements first in, first out. The head of the queue is that element that has been on the queue the longest time. The tail of the queue is that element that has been in the queue the shortest time. and the new elements are inserted at the tail of the queue, and the queue retrieval obtain elements at the head of the queue, which means you obtain from the one that has been in the queue the longest time. So that is what we observe with this. I hope this actually makes sense. So there's something else that I want you guys to observe. I'm going to increase this to 5 and immediately increase this to 5, and we run this. We notice that the number of people that are allowed into the interview room suddenly becomes 5. And what you have to observe is that 5 is calculated. You take this capacity, you add it with the number of threads that are taking out tasks into the queue. That's why you get this 5, and then everything else just goes on like that. If you increase this, let's say, to 3, you observe that this number would change as well here. You see now that you have 6 people into the queue allowed. Let's increase it to 5. You see now we have 8 people into the queue. Then from there you take out, you interview 3 people, take them out, then you create space for someone to come in until all candidates are interviewed. So now how do we know that all candidates have been interviewed? So we know that all candidates have been interviewed if when we take someone in the queue, or when we take some task in the queue, it is complete. Then we know that all candidates have been interviewed. As long as when we are trying to take from the queue, we notice that we don't get complete, it means we still have more candidates in the queue. And remember, we are working on the same queue instance because this queue was created somewhere else and is passed to each single one of them. So to the producer, which is the thread, or you can say the thread that the worker thread task that actually puts more work into the queue, as we can see here. We are just putting more work. You can think of this candidate as a task. You're putting more work into the queue. That's all you do. So you put like 10, and then you say, you notify that all candidates have scheduled, then you say complete. That means you have put everyone into the queue. Then what you do next is the interview desk is the one that will say, okay, we are just taking candidates from the queue. That's what it does. It takes candidates from the queue. But you must be careful that the one that adds candidate into the queue cannot add more than enough. Like we saw here when we ran this code. Let's come here. Let's take it back to 3. We see that it only adds 6 into the blocking queue. So that means that in this array, when we get to 6, we put the last 6, we come back, we try to put, we are blocked because the queue is full. We have to wait now. We have to wait. If you can come here and read what this says. It says, insert specified element into the queue, waiting if necessary for space to become available. This is what happens. We are waiting now because the queue is full, and we are waiting now. What we are relying on, this this task is now relying on this task to take out elements from the queue so that it can be able to add more. This is what we see with the blocking queue.